Okay, let's continue with number 12. Number 12 is about graphing some absolute value functions, and this was also part of this chapter. So let's begin with number 1. Here we go. Number 1 says y equals the part A says y equals the absolute value of x minus 3. In all of these problems, what you're looking for are three things. You're looking for h, you're looking for k, and you're looking for a. And remember what I said, h is inside of the absolute value. H is the homie, right? Inside the absolute value. K is outside, has been kicked out. A is first. That means A is in front of the absolute value. Outside, but in front. So h would be here inside the absolute value with x. It's always going to be x minus something or x plus something. Since this one doesn't have anything, x minus or x plus, that means h is 0. Because it's not there. K is over here, kicked out at the end. In this case, it's negative 3. And A would be here in front of the absolute value. There's nothing there, which means that A is 1. If there isn't anything there, that means there's a 1 there because it's 1 times the absolute value of x. Okay, which is different from h. If there's nothing there inside the absolute value, that means h is 0 because there's nothing there. All right, so these two tell you what the vertex is. The vertex of this function is 0, negative 3. That's where you begin your graph. Okay, so the vertex is 0, negative 3. That means here is where you put your first point. And then use the slope. This is A. A tells you what the slope of the right side is. Okay, the left side is the exact opposite of it. But the slope of the right side is 1, therefore the slope is 1 over 1, which means that from that vertex go up 1 over 1, up 1 over 1, up 1 over 1, and so on to make your graph. And it goes that way from the vertex. And on the left side is the exact opposite. Up 1, left 1, up 1, left 1, up 1, left 1, and so on. Because it is a mirror image. It's a perfect reflection. And there you go. That's the graph. I did forget to graph the parent function, which starts at 0, 0 and goes that way. You guys are familiar with that. And how that helps me is that I know that the original function, this one, moved down 1, 2, 3 units, which is exactly what k says. Okay, let's do b the same way. I'm going to start by finding h and k and a. In this case, h is right here. It's negative 2, it says here, but remember whatever you see inside the absolute value comes out and changes sign. So it's actually positive 2. Okay, h is weird that way, and that's the opposite sign of whatever you guys see in there. K is 1. All right, you guys see that here at the end. And A is in front here, which is 1 again. The vertex is 2, 1. HK. That's the vertex. So you start your graph there. Before I start graphing, I'm going to do the parent function. Here's the parent function. Starts at 0, 0 and goes up 1 over 1, and then the exact opposite on the other side. And then the one I'm going to graph starts at 2, 1, which is here. This is the vertex. And then from there, the slope is 1, so that means up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, and so on. So it goes like that. And on the left side is the exact opposite. Up 1, left 1, up 1, left 1, up 1, left 1, and so on. So it goes like that. The arrow going that way. And there you go. Seeing the parent function in the final one helps us to see what happened to the parent function to turn it into this one. In this case, you guys can compare just the vertex and see that it moved to the right 2 units and up 1, which is exactly what h and k say. To the right 2 units because it's positive, up 1 because it's positive. Okay, let's do a couple more. Here we go. In this one, h, k, and a. H, once again, inside the absolute value, the opposite sign, so negative 1. K is negative 2, A is 3. I'm going to write it as a fraction so I could graph it. The vertex is negative 1, negative 2, right? HK. I'm going to start by graphing the parent function. Start at 0, 0 and go up 1 over 1, like that. And then I'm going to graph the new function by finding the vertex, which is negative 1, negative 2. Right here is where you start. The slope is 3 over 1. That means go up 3 over 1. Right here is where it's going to end up. Up 3 over 1. Up 3 over 1 from the vertex. And you draw that line. On the left side, do the exact opposite. Go up 3 left 1. Up 3 left 1. And you go like that. That line came out a little slanted, but that's correct. And there you go. There's the parent function in black and the new function in blue. All right, let's do it again. In this one, we're going to find h, we're going to find k, and we're going to find a. H is -1. Notice it says +1, but it's always the opposite for h, so -1. K is the same. It's 3. It does not change signs. Neither does A. Whatever sign you see, that's A, -1/2. And it's already a fraction, so that helps us a lot. The vertex, I'm going to write it as an ordered pair, -1, 3. That's HK. All right, we're ready to graph. I'm going to graph the parent function first. From 0, 0, go up 1 over 1. There it is on the right side, and there's the right side. Left side. The new one is going to be starting at -1, 3. So up here is where it begins. And the slope is -1/2. That means from this point, go down 1 over 2. Down 1 over 2. Like this. And on the left side, do the exact opposite. Go down 1, left 2. Down 1, left 2 to go that way. And there you go. There's your parent function in black and your new function in blue. All right, number 13 is for you guys to practice on your own. So go ahead and do number 13, A, B, C, and D on your own. Pause the video right now, then come back and check your answers. Go ahead and pause right now. Okay, here you go. These are the correct solutions for A, B, C, and D. You can see the black one is the parent function. The blue one is the final function. In part A, I found that h is 0, k is -2. So the vertex is 0, -2 right here. And the slope is 1 over 1 because A is 1, so up 1 over 1, and then do the exact opposite on the other side. For B, H is 3, K is 2, A is 1, the number in front. So the vertex is 3, 2, that's where I started. And the slope is 1, so up 1 over 1, and the exact opposite on the other side. For C, H is -3, K is -1, so the vertex is -3, -1 right here. A is 2, that means that the slope is 2 over 1 on the right side of the vertex. On the left is the exact opposite. And finally D, H is -2, K is +1, so the vertex is -2, 1 right here. And A is -1/3, that means go down 1 over 3, down 1 over 3 on the right side, and on the left side is the exact opposite. All right, let's move on to 14. It says describe the transformation from y equals absolute value of x for each function. So y equals absolute value of x, that's the parent function. So it's basically saying what happened to the parent function to turn it into this right here. Okay, and it's actually really easy, just like the ones we did before. We don't even have to graph it. All you have to do is find h and k. So here we go. Let's get started with a. First thing you do is find h and find k. And a also, if it's there. But since there's no a, there's only 1, then that doesn't really do anything. If a was any other number, then it would be like a vertical stretch or a vertical compression or a reflection, right? But since it's just 1, it doesn't do anything. It leaves the graphs the same. But h and k are there, so they do things to the graph. So in this case, h is -4 and k is -3. So h is -4 means a translation left 4 units. How do I know it's left? Because it's negative. H is always going to do things either left or right. K is always going to do things up or down. So for K, what I'm going to say is it's a translation down 3 units. So left 4 units, down 3 units. H is -4, that means left. K is -3, that means down. Again, here we go on B. H is 4, right? K is 3. So H is 4 means translation right 4. Positive means right. 4 units. K is 3, that means translation again up 3 units. Here we go again. Let's do it again for C. H is 3, K is 4. So if H is 3, that means translation, right? H and K, that's all they do. They do translations or shifts, which is the same thing. They move the graph. Translation, it's positive, so that means right 3 units. Remember, H only does things left or right. K goes up or down. So K is a translation also, but it's positive also, but that means up for K, 4 units. So this is basically, what we're saying is that this is basically the same as the parent function. All that happened to it is that it moved to the right 3 and up 4. So the vertex is at a new spot, 3, 4, instead of 0, 0. Here we go again on this one in D. H is negative 3, K is negative 4. So H is negative 3 means translation left 3 because it's negative. And K is negative 4 means another translation. But this one is down because it's negative 4 units. There you go. All right, your turn. You do 15 on your own. A, B, C, and D. So go for it. Start it out. All you got to do again is describe the transformation, just like I did up there on number 14. So go ahead, pause the video right now, come back and check your answers. Okay, here you go. Here's the solutions for A, B, C, and D. In A, H is negative 1, K is negative 2. So it's a translation left 1, down 2. In B, H is positive 1, K is positive 2. So it's a translation right 1, up 2. In C, H is negative 2 and K is negative 1. So it's a translation left 2 and down 1. And in D, H is positive 2 and K is positive 1. So it's a translation right 2, up 1. All right, let's continue with number 16 right away. This is an old type of question. We did this before. So 16a, let's get started right away. The first thing you look for when you're solving a system of equations like this one is to look out for opposites. Are there any opposites here that if you were to just combine them together, they would cancel? And the answer to that question in this case is no. If I combine these, they do not cancel. They do have opposite signs, but it's not the same number, right? We want this to be a 3, and that way they can cancel. These are not even the same number, and they have the same sign, so no, they wouldn't cancel. So the best thing to do here is to try to cancel the x's by simply multiplying this one times 3. And that way it will be 3x, and 3x will cancel negative 3x, right? So what I'm going to do is I'm going to multiply the entire bottom equation by 3. I'm going to leave the top equation the same. Do not change it. Negative 3x plus 3y equals 15. But I'm going to multiply the bottom equation by negative 3 all the way through. Everything gets multiplied by negative 3, including the number on the other side. So it will be 3x plus 6y equals negative 15. And now you can basically combine them together. And what's going to happen is that 3x and the negative 3x will cancel. And nothing else will cancel. 3y and 6y will make 9y. 15 and negative 15 will make 0. Divide by 9. And be careful, do not say, oh, no solution. This is just 0. Y is equal to 0, right? If we want to find x, we take that y value. We go back to any of the originals. I like this one. It looks like it has easier numbers. And plug in the y. So let's do that, watch. I take x plus 2y equals negative 5. I plug in the y equals 0 right there. So x plus 0 equals negative 5. So that just means x, right? X is equal to negative 5. And there's your solution. Negative 5, 0, right? xy. Oh, I just noticed the question. It says, what is the y coordinate only? So it's only asking for the y. Then you're done right here. Right? No need to plug in to find the x. All right, so I'm going to skip B, C, and D and go right to E. And then I'll let you guys work on the other ones. Okay, so let's go all the way up to E and do that one. And then you guys will do the other ones that I skipped. So here we go. In this one, these have the same sign, but they're not the same number. These have the same sign, but they're not the same number either. So neither of them are opposites. We need to figure out a way to make them opposites. Okay. I notice that this is a 2 and this is a 3. So if I multiply this by 3, it'll be 6. And if I multiply this by 2, it'll also be 6. So let's start with that. If I multiply this one by 3, it will be 6. If I multiply this one by 2, that will also be 6. And those are the same number. However, they still will have the same sign, right? That would be negative 6, that would be negative 6. So I don't want that. I want one of them to be the opposite. So what I'm going to do is make it, instead of 3 and 2, make one of them negative. Just one of them. It doesn't really matter which one. I'm going to do that one. So if I make that one negative, then when I distribute it like that, and make this one positive, when I distribute it like that, here's what I'm going to get. For the top one, I'm going to get positive 6x minus 6y equals negative 12. Let's fix that too. There you go. For the other one, I'm going to get negative 6x, because positive times negative is negative, positive 6y, and for the y value, I'm going to get, for the other side, I'm going to get 12. And now when I combine these, 6x and negative 6x will cancel. But also 6y and negative 6y will cancel. So that means that on the left side, I have nothing left, just a 0. On the right side, 12 and negative 12 also cancel. So on the right side, I also have 0. Now, when this happens, that the x and the y both get eliminated, check the equation you get. If it's something that is true, then what we say is infinitely many solutions. If you end up with something that is not true, like 0 equals 5 or 0 equals some other number, if it's something that is not true, then you say there are no solutions. Okay? What that basically means is that if I was to graph these two lines, they're the same line. One is on top of the other. They're what we call identical or coinciding lines. If I had no solution, if it was 0 equals some other number, no solution, then that would mean that the lines are parallel in that case. Okay? But in this case, they're identical, which means infinitely many solutions. Okay, so what I want you guys to do is go and do B, C, and D, the ones that I skipped, and also F, right? So B, C, D, and F on your own. So you can go ahead and pause the video right now, do those on your own, and then come back to check your answer. Go ahead and pause the video now. Okay, here you go. Here are the correct solutions. For part B, what I did is I multiplied the bottom equation by negative 5. That way I would have negative 5x and it would cancel with 5x. I got negative 7y, and on the other side I got negative 15, which combined with the 1, it got negative 14. Divide by negative 7 and you're done. Because remember, you're only looking for the y value. So y equals 2. In part C, I multiplied the bottom equation by negative 2 to make it negative 2x, and positive 2x would cancel, which they did. Make sure you multiply all of them. So negative 2 times negative y became positive 2y, and that became negative 10. This became 5y. This is negative 10. When I divided by 5, I got negative 2 for y. In part D, I decided to not multiply at all. Just go ahead and cancel the y and the y, because they're perfectly set up to be canceled. And that left me with x equals negative 2. But that's not what it's asking for, right? It's asking for y. So what I did to find y is I took the equation. Which one did I use? The top one. It doesn't really matter which one you use. You're going to get the same answer. But I chose the top one, and I plugged in the x equals negative 2 right here for x. And I got 6 plus y equals 15, subtract 6, and I got y equals 9. And that's your final answer for y. You could, of course, multiply the top one by 4 and the bottom one by 3 to make it negative 12x and positive 12x, and then they would cancel and solve for y directly, but you're going to end up with the same answer. I just chose to go ahead and cancel them already since they were already opposites. And finally, for f, here's what I chose to do. I figured it would be easier to cancel the y by multiplying it times negative 6, because negative 6 times negative y would be positive 6y. So once again, I ended up canceling the y first before the x. This became negative 24x, and this became positive 6. So when I combine them, this is negative 19, and this is also negative 19. Divide by negative 19, and I got x equals 1. I took that x equals 1, plugged it into either one of the originals. I chose this one, and I got 4 minus y equals negative 1. Subtracted 4, divided by negative 1, and I got my solution, which is y equals 5. Okay, here we go. For number 17 through, I think it's 19, 20, it's the same idea for all of them. And they're all pretty simple. Watch. Basically, every time you have an allowable range or an allowable set of numbers that you can use, what you're going to do is you're going to set up an absolute value equation starting with x minus something. X minus something, the something is always what is it that you want. Okay, if I set my thermostat, what I want is 70 degrees. But it can vary, right? It can get hotter, it can get colder. So that's why we have the absolute value, because if the number is hotter, then I'm going to get a positive number. That's what I want. It's going to be a little bit over. But if the number is colder, then this is going to give me a negative number. But I want to know how far away from the actual number is. So we use the absolute value to make it positive. And then if they tell me that it can vary at most 3 degrees, that means that the temperature here will be less than or equal to 3 degrees around close to 70. Okay, so it cannot pass 70. It cannot pass 3 degrees either above 70 or below 70. And then all you got to do is solve that. That's actually pretty simple to solve. We've been solving these. First thing you check is what kind of inequality, which is and in this case. You split it up into two. The first one is going to be simply x minus 70 is less than or equal to 3. The other one is going to be x minus 70 is greater than or equal to negative 3. You solve them both. This one simply add 70 and you're done. It's x is less than or equal to 73, which makes sense. The temperature should stay below 73. For the other one, you're going to also add 70, and you're going to get x is greater than or equal to 67, which also makes sense. The temperature should be above 67. And the word and in between to show that it's an and inequality. So the temperature should be between 67 and 73. The other way we write it is like this. 67 is less than or equal to x is less than or equal to 73. And finally, let's graph it. Here's a number line. Find 67, find 73. Close circle on both of them and shade in between. Done. So once again, the number inside the absolute value with the x is what you want. The number on the other side is what you can be allowed to vary by. I can vary by at most 3 degrees, so we put 3 degrees there. Less than or equal to, because you want it to be less than 3 degrees. You cannot pass 3 degrees. Let's do it again. The cruise control on my car is set to 65 miles per hour. The cruise control allows the speed to vary no more than 2 miles per hour. So once again, I set up an absolute value, x minus. What do I want? I want 65. But it can vary no more than, that means less than or equal to 2. And there you go, solve that. I'm going to solve it once over here and once over here. First, before I do that, check what kind of inequality it is, and you guys should see that it's an and inequality because it forms a D when you put that vertical line. So it's going to be on the left side, x minus 65 is less than or equal to 2. On the right side, x minus 65 is greater than or equal to negative 2. We solve them both by simply adding 65. And they're both pretty easy inequalities to solve. This one's going to be x is less than or equal to 67. And, right, it's an and inequality. We solve the other one by adding 65 also. And that one's going to be x is greater than or equal to 63. And there you go. The solution is a number that is smaller than 67 and greater than 63. So somewhere between 63 and 67. In the other form, we write it like this, right? And inequalities, you can write it in this form as well, which is a compound inequality, like that. And finally, let's graph it. 63 is right here. 67 is here. Put a closed circle on both of them because of the equal sign. And once again, it's an and inequality, so shade in between. Okay, 19 and 20 are yours. Go ahead and try those on your own. They're very similar to the ones that I just did. So pause the video right now, go ahead and do them, and then come back and check your work. Go ahead and pause the video right now. Okay, here you go. Here's the answer for 19 and 20. In 19, I started with x minus 150 inside the absolute value is less than 3. And I ended up with an and inequality that says that x is less than 153 and x is greater than 147. Oh, you know what I forgot? I forgot to write it in the other form, so let's do that right now. 147 is the smallest number, and 153 is the largest number. So there you go. X is somewhere between 147 and 153, which makes sense. That's where Peter is trying to maintain his weight. His goal is 150, and he doesn't want to vary more than no more than 3 pounds. So 147 is the lowest, 153 is the highest. In number 20, same idea. And it looks like, again, I forgot to write it in the other form. It's going to be 99 is less than or equal to x is less than or equal to 101. Which is my answer that I got by solving this inequality right here, x minus 100, and then this number is but what it can vary by. It can vary by at most 1 capsule. So we want 100, but it can vary by 1. So x is less than 101, x is greater than or equal to 99. So between 99 and 101 is the allowed range for these jars of capsules. Alright, we're almost there. These are the last 3 problems, 21, 22, and 23. Let's get going on number 21. Alexis has collected 30 Pokemon and is collecting 3 more each week. Okay, let's set up an equation already for that one. He or she has collected 30 Pokemon. So let's start with 30. And is collecting 3 more each week. Plus 3 per week. So starting with 30 plus 3 more per week. So in this case, x represents the number of weeks. Let's write that down. Number of weeks. So 30, what he has, plus 3 per week. So if he collects 1 week, that's 3 times 1, plus 30 that he already had, that's 33. 2 weeks, that's 3 each week, that's 6. 3 times 2 is 6, plus 30 is 36. See how it works out if you plug in the number of weeks. That's Alexis. So Alexis. Anna is collecting 5 each week. Okay, so Anna is 5 each week, but started with 20. So she started with 20, but 5 each week. So 5x. All right, now we can actually answer the question then with that information. This one is Anna. So it looks like Alexis has more to begin, but Anna is increasing by more. She's getting more per week, right? The question A is, after how many weeks will Alexis and Anna have the same number of Pokemon? So when will they be the same? To answer the question, you simply set both of these equal to each other. It's basically going to be 30 plus 3x equals 20 plus 5x. And solve those two. We're going to isolate the x by moving it over to the right side. It looks easier to move 3x than it is to move 5x. So that's 30 equals 20 plus 2x. Then we're going to subtract 20 here. That's going to be 10 equals 2x. And finally, we're going to divide by 2, and x equals 5. Remember, x is a number of weeks, and that's exactly the question. After how many weeks will they have the same number of Pokemon? The answer is 5 weeks. In 5 weeks, they'll have exactly the same number. And question B is, how many Pokemon will they each have? So when they do have the same amount, how many is that? So what you do is you take either Alexis or Anna and plug in 5 to see how many that person has. Let's use Alexis. So Alexis is 30 equals 30 plus 3x, right? Is that correct? Let me go back up again. Yep, that's right. So plug in 5 because it's 5 weeks in which they both have the same amount. So 30 plus 3 times 5. 30 plus 3 times 5 is 30 plus 15. And that's 45. So that means that Alexis will have 45 Pokemon. Will Anna have the exact same amount in 5 weeks? Yeah, she will. That's what we said, right? After how many weeks will they both have the same amount? After 5 weeks, they're the same. That's what we solved. We set them equal to each other. So in 5 weeks, if Alexis has 45, Anna has 45. Watch, let's prove it. Anna is 20 plus 5x. Let's plug in 5 also. That's 20 plus 5 times 5. That's 20 plus 25. And that is 45 Pokemon. So she has 45 in 5 weeks also. So after 5 weeks, they both have the exact same amount, which is what we said in problem number 8. Okay, part C. Who will have more by week 10? All right, so to find that, plug in 10 into both of them, Alexis and Anna, to see how many they have. So let's use Alexis first. Alexis is, we said, 30 plus 3x. Let's plug in 10. 30 plus 3 times 10. That's going to be 30 plus 30, so 60. Alexis has 60 in 10 weeks, week 10. Anna will have 20 plus 5x, right? Plug in 10 there. 20 plus 5 times 10. 20 plus 50, and that is 70. So it looks like Anna wins after 10 weeks. And that's our answer. Anna will have more. And we just proved it. 70 to 60. When you guys do this question on the test, it's not enough to just say who has more. Prove it. Show me that this one is more than that one. If I left this all not there, if I just erased all this and all I wrote was Anna will have more, it doesn't matter that I'm correct. That's a guess. Okay, you must show with the work that you know why you say that Anna has more. Okay, 22. Rick has killed 350 zombies and kills 2 more per day. All right, let's set up an equation for that. Rick, he has killed 350 and 2 more per day plus 2x. In this case, x represents number of days. Carl has killed 100, so Carl is 100, but kills 3 more every day, so plus 3x. The question A is, after how many days will Carl catch up to Rick? Meaning they will have the exact same number of zombies killed. So when will they be the same? Set them equal to each other. So it's going to be 350 plus 2x, that's Rick, equals 100 plus 3x, that's Carl. We're going to isolate the x by subtracting 2x here. We're going to get 350 equals 100 plus x. Then we're going to subtract 100 to leave the x by itself. And that's 250 equals x. Remember, x represents the number of days. So it's going to take 250 days for Carl to catch up. Because Rick has way more right now. Alright, moving on to question B. How many zombies will they have each killed by then? So yes, they will have the same amount. Carl will catch up. But how many zombies is that in 250 days? So what you need to do is plug in 250 into both of them, either Rick or Carl. Actually, you just need one of them to see how many they have. So Rick is 350 plus 2x. Instead of x, I'm going to plug in 250, which is the number of days. That's 350 plus 500, and that's going to be 850 zombies, or walkers. So in 250 days, Rick will have killed 850 zombies, which is the same number as Carl. So you can try that by plugging it into Carl also. You'll get the same thing. Plug in 250 right here. 3 times 250, 750 plus 100 is 850. They both have the same number. Question C. Who will have killed more in 1 year? 1 year is 365 days. So plug in 365 into both of them to see who has more. So Rick is 350 plus 2 times x, which we're going to plug in 365, right? 1 year. And that's going to give us 350 plus 2 times 365 is going to be 700 and, what is that, 30? Right? Add those two together and you're going to get 1080. That's a lot in 1 year. Carl, let's do Carl, is 100 plus 3 times, once again, 365 is what we're plugging in, right? So when you do that, 3 times 365, you're going to get 100 plus 3 times 365, that's going to be 3 times 5 is 15, 3 times 6 is 18, plus 1 is 19, carry the 1, 3 times 3 is 9, plus 1 is 10. 1095. Let's hope we did that correctly. Yep, I think we were right. 100 plus 1095 is 1195 zombies for Carl. And it looks like, because Carl is going at a faster pace now, even though Rick started with more, 350, and Carl started with 100, Carl is going at a faster pace of 3 per day, while Rick is going at a pace of 2 per day. It looks like if it's 1 year later, Carl wins. 1,195 zombies. Alright, your turn. Number 23, the last one is yours. So go ahead and work on that one on your own, and then come back and see the correct answer. So go ahead and pause the video right now. Okay, so here you go. Here's the answer to number 23. If Anthony has watched 400 and watches 24 more per year, Antonio has watched 280 and he watches 36 more per year. This is Anthony's equation, 400 plus 24x. This is Antonio's, 280 plus 36x. I set them equal to each other. Oh, and x is a number of years, right? So I set them equal to each other. I solved it, and I got x equals 10. So in 10 years, they both will have the same number of movies. How many movies will they both have watched at that time? I plugged in 10 into Anthony, and I got 400 plus 240 equals 640. So they both will have 640 movies. You could also plug it in into Antonio. You're going to get 360 plus 280, which is still 640. Who will have watched more in 10 years? That's exactly the number of years it will take for them to be the same. So in 10 years, nobody wins. They're tied. Okay? If I had asked you for 11 years, then there would probably be a winner who has more. But in 10 years, they both have 640, so the same. Alright, that concludes the review. Make sure you guys are watching this and reviewing it for your test.